Thank you to our sponsors or organizers. I'm really excited to be here and talk to you all about Elm tonight. My name is Mike Anderson. You can find me on Twitter and GitHub as Aetherin. I work at a place called Space 150. We're near here. I don't remember the direction. And we're always looking for cool, talented people, so, Google us. And lastly, before I get into this, please ask me questions. If you have something, I want this to be a conversation if that's helpful. So do not feel like you shouldn't ask me a question. I'm going to assume that we all have like basic familiarity with JavaScript things. It's also nice if you have functional programming knowledge. If you understand things like recursion, it's not necessary. I will call out things like pattern matching. If that means something to you, great. If it doesn't, don't worry about it. So, what is Elm? Who has heard of Elm? Who knows? Okay, cool. Does anyone know what Elm is? Like enough to give a definition of like, this is what Elm is. Yes. So we're going to change this. So Elm is a language for writing web apps, and its goal is to be very reliable and performant. It's a language that compiles to JavaScript. It's kind of similar to like CoffeeScript in that way, except that CoffeeScript is like a different syntax for writing JavaScript. Elm is a completely different language. It just happens to compile to JavaScript. Yeah, that point. It was designed by a guy named Evan Czaplicki as part of his thesis in 2012. His thesis was on functional reactive programming, if you're familiar with that. Elm was very functional reactive programming-ish when it started. They've removed some of that. Some of the things that made it a little too complicated they removed, so it's a lot easier to get started. And recently, there's a company called No Red Ink. They're an education startup out in San Francisco. And this year, they hired Evan to just work on Elm full-time. They have about 55,000 lines of code in production, Elm code. And they've been using it for about a year and a half, and they've had no runtime exceptions, ever. So Track.js would not be useful to them, I guess.
Lies!
A caveat to that is that they have had runtime exceptions. It's just never been Elm's fault. They've also got CoffeeScript and JavaScript running.
Never been my fault either.
That's true. Yeah, so they've, 55,000 lines over a year and a half, no runtime exception, sounds pretty incredible. Yeah, so why Elm? The first point, no runtime exceptions, right? You're never going to see undefined is not a function, or can't call this method on this thing because it doesn't exist. That's just not possible in Elm. You also get great performance out of the box. It's possible to optimize it further if it's an issue. One of the developers at No Red Ink, I went to a conference recently where he gave a 2-day workshop on Elm, and he mentioned that they've never really had an issue with performance, maybe a couple of times, and so you don't generally have to try really hard to optimize it and get good performance out of Elm. Just the nature of how it works, it's got a virtual DOM implementation. It's just kind of fast by default. It has enforced semantic versioning. So if anyone's ever been stung by having a package update a patch version and break your application, that's not possible in Elm because the Elm compiler and the publishing system can look at your application and figure out if types have changed that would break other applications. So it's not possible to publish an Elm package that could break other people's code, which makes it even more fun to contribute Elm packages because you're not like, oh, I hope this doesn't break anything. Push that. Can't happen. And lastly, writing Elm is really fun. It's one of the goals originally was to just be delightful, and in my experience, it has been. Speaking of my experience, I have been like interested in Elm and dabbling in it for about a year. My first like public commit, if you look on GitHub, is from like May, and I've been kind of using it on and off over I guess the last few months. I want to start this talk, since we didn't have any lightning talks today, I'm going to start with a mini lightning talk on some current JavaScript trends, and we'll use that as kind of a stepping stone to get into Elm. So we're going to look at components. I should also mention that specifically I'm going to focus on JavaScript trends in the React community because that's where I had the most experience, but these are also relevant in places like Angular, Ember. Other communities are also using patterns like this. So we're going to look at using components to build UIs. We're going to look at immutability in your data. We're going to look at type systems. And we're going to look at data flow, specifically this unidirectional data flow. And we'll get to that in a little bit. So first up, components. Does this look familiar to anyone? Have you seen patterns like this? So this is React. This is JSX. And by writing this, if you render this, you might get something that looks like this, depending on your style sheets. But JSX was written to declaratively allow you to define bits of your UI. And then components can also handle interactions like clicks. They can have local states, so you might have a timer component that keeps track of its own countdown, and then can fire a handler when it's done, that sort of thing. And then you can use these components to build larger bits of UI. So maybe we have a card component that displays like a box in your UI. We might have a user picture component that takes a user's ID and ends up rendering an image with a avatar URL using that ID. And you might end up with something like this. So sort of the ideal here, if you've seen this, this is not my idea, but the general ideal goal of building a system this way is that your UI ends up being a function over your application state. And specifically what that means is if your application state is the same and you render twice or 3 times or 4 times, you should always get the same UI. And the nice thing about that is you can look at that function and figure out exactly what your UI will look like for any given application state. It's really easy to think about what is it going to look like if the user is logged in and I render this component. Building your UI this way makes that really easy. So that's enough about components for now. We're going to talk about immutability. Has anyone used Immutable.js or Seamless Immutable or Mori, anything like that? One in the back, a couple over there. Okay, so who's familiar with immutable data on a larger sense than like just those specific libraries? Okay, so immutability means that things can't change, and the opposite of that is mutability, which means that things can change. So this is using a library called Immutable.js. So we're going to declare that X is the immutable list 1, 2, and 3. And then, fairly reasonably, we're going to push 4 into that list. And you might expect that your list is now 1, 2, 3, 4, but it's not. It's still 1, 2, and 3. So we can't update data if it's immutable, that it can't change, it's unchanging. So how do we change data when we're using immutable data? What you can do is update the binding. And so you can say that X is now equal to X, but push 4 onto it. And so now X is 1, 2, 3, 4. Cool, right? Like, why is that useful? It's really useful because specifically Immutable.js and some of these other libraries use a structure called persistent immutable data, which means that when you push 4 onto that, it still keeps 1, 2, and 3 around, and then just gives you a new copy with that 4 added. So if you still wanted to keep X, you could say Y equals X push 4. And X and Y are still what you set them to be originally. X is still 1, 2, 3, Y is still 1, 2, 3, 4. This makes, like, maybe I want to add undo to my application. I can just keep a list of all my old states and then just transition back through them. It also makes it, it gives you confidence because you can pass your data to a function and not worry about the function changing your data. If you've ever had that happen, that's not fun. So in general, it lets you not have to worry about like things mutating your data, and it makes some other things really easy too. Questions so far?
With immutability, have you found issues with memory footprints? Is that anything?
Yes. So that's a great question. So the question is, are there ever issues with like using too much memory because we're keeping all these old copies of data? And the answer is that the implementation specifically, I should have a diagram of this, but basically these libraries will figure out the smallest copy of nodes that they need, and then they'll point back to the originals. So you're only ever like adding the new nodes that you need. So it is actually very memory efficient. It doesn't match the performance of like mutable data, but it gets close. Anything else? All right. So types. Who is familiar with type systems or types? Cool, more people than immutability. Who's familiar with types because of type errors in JavaScript? Okay, so a type system means that everything in your system has a value, or has a kind of thing that it is. So you might have strings, you might have numbers, and JavaScript is dynamically typed, it's not strictly typed. What that means is that you can pass anything you want to a function. It might be a string, it might be a number, it might be an object, you don't know. And there are efforts to add a system to JavaScript that allow you to say, this function should only accept this kind of thing. And what that lets you do is not worry about, what if someone passes me something that I'm not expecting? So for example, we might declare that the type pizza is the string, the pizza emoji. And then we have a function, eat. The colon pizza means that this function only accepts pizza, the type pizza. So slice should only ever be the type pizza. And if we look down here, if you try to eat 7 slices of pizza at once, you're going to get a type error. And Flow is just helping you out here. Flow is a type system. It's just, hey, slow down. Maybe you want to get these, like, eat 7 times with single slices of pizza. But this is really great because it lets you say, this function should accept this kind of values, should return these kind of values, and then you can have more confidence that your system is doing the right thing as a whole if you know that each individual piece is doing the right thing with its data, and you know that nowhere in your code are you passing a shoe instead of a pizza into your function. Questions on types?
What is the margin of value add using types versus not?
Yeah. So so the question is, what is the value, and how much value do you actually get out of adding? Yeah. How much value are you adding by adding types to your program? And the answer is it depends. If you're building something small, maybe you're not worried about it. If you're prototyping, it's probably not important. But when you start scaling up, there's this diagram that shows a curve of if you have dynamic types, it starts out, you're really productive, and then as things go bigger and bigger and bigger, you get less and less productive because I changed something over here, and something over here was expecting the wrong type, and now I've messed things up. And then static languages that have strong types might start less productive, not unproductive, but they might start less productive. And then as you increase the size of your code base, it's easier to make changes, because if you break something over here, the compiler or whatever is managing your type system is going to tell you about it before you deploy it to production, and Track.js tells you, hey, you broke a thing. Great question. Any other questions? Types?
So the syntax is the same on the return if you want to return a type?
Yeah, so you'd put a colon after the closing parenthesis. The question is, the syntax is that the same for return values, and yeah, you just put a parenthesis after the ending paren in the function declaration and the return type. Anything else? Yes.
So is the Elm compiler strongly typed too?
Yeah. So the Elm compiler is strongly typed, and we'll get to that. We'll talk about Elm's type system, not exhaustively, but a lot. So let's move on to data flow. So there's kind of this trend in JavaScript, again, specifically in React, that your data doesn't do two-way binding, like you've probably seen, where your view component can probably change data, and your model component controller thing can change data, and they tell each other about it, and that happens. Facebook launched this library, well, more of a pattern called Flux, where we'll look at a diagram in a second, but essentially things flow one way. So you have a copy of your state, you have a way to update it, and your views are just updated based on that state, and then your views can trigger actions that go back around and start at the beginning. But there's no two-way binding. Everything always just flows one way, which we call unidirectional because it sounds smart. So Flux works pretty well, and then someone named Dan Abramov decided that there were some things maybe that could be improved. Coincidentally, Redux, the library that he wrote to improve on those things, was inspired in part by Flow, or in part by Flux, in part by ClojureScript, and in part by Elm. So if you are familiar with Redux, a lot of the concepts that you're going to see in Elm should be familiar to you. Ember has something similar. I think they say data down, actions up. Is that anyone Ember? But same kind of concept, like data goes down into your views, actions come back up and update the data, and then it goes back down. So that looks like this. This is a diagram that Facebook drew about Flux. So you have a dispatcher. The dispatcher is what's responsible for receiving actions and updating your state. You have a store, and when the store changes, views can be subscribed to the stores and know when they changed. It's a very good pattern. There are some improvements in Redux that we're not going to touch on, but this idea of this flow is very powerful. So that's the lightning sub-talk on JavaScript trends. Any questions before we move into Elm? Cool. All right. It's Elm time. So we're going to hit on each of those points and how Elm answers each of those. So in Elm, instead of components, our entire UI is in a tree similar to the component tree that we saw earlier, except instead of components, everything is just functions that return some HTML or virtual DOM nodes. Everything in Elm is immutable. It's really nice having this baked into the language instead of using something on top of JavaScript like Flow or TypeScript. Strong types, like we talked about. The Elm compiler is going to make sure that if you say, I want a number, you're always going to get a number. And it will verify that throughout your whole program, throughout any third-party code that you're using. And finally, there's a thing called the Elm Architecture, which is the part specifically of Elm that Redux was inspired by. And we'll talk about that more later. So this is a very small look at what Elm looks like. Every Elm program is going to have this main declaration. That's the entry point to your application. It's like C. There's a lot of other languages that follow this pattern. So your application will have at least main. And in this case, we're saying that text is just going to be hello Elm. We'll talk about exactly how that works in detail in a little bit. So we'll look at some primitive types. The dash is comments in Elm. That's the only comment syntax. There's not like a slash slash and a slash asterisk. It's just double dash. So you'll notice that we don't have a number type like JavaScript that can be either an integer or a float. We have specific integer and float types. And those cannot be used in place of each other. If you want to turn a float into an int, you have to use the round function, for example. We have strings, just like in JavaScript. They always use double quotes, so you won't see single quoted strings in Elm. We'll look at some data structures. So the first one's called a tuple. It can have, I don't know if there's a limit on how many things you can put into a tuple, but it's useful for grouping a few different things together. You can use multiple types of values in a tuple, so I can have a string and then an int and then a float, and that's fine. Or the other way around, string, float, int. There are lists. Lists only can contain a single type of thing. So I can have a list of ints, I can have a list of strings, I can have a list of floats, I can have a list of tuples, but the tuples have to have a type. We'll talk about type aliases in a little bit.
Should be similar data structures?
What was that?
Should be similar data structures?
Oh, sorry.
Data types should be similar in this too.
So
Data
I
type should be similar in this list.
They all have to be the same in the list.
Same data type should be.
Oh, yeah. So they have to be the same data type. Yeah, yep.
Within the tuple?
Yes. Not within a tuple. So a tuple, right. I think I understand what you're asking now. So if you have a list of tuples, all the tuples have to contain the same like string, float, int, that structure.
In the same
yes.
pattern?
Pattern should be same.
Yeah, and the order matters.
The order matters.
Yep. Great questions. Thank you. So we've got lists that always contain the same types. Important to note, there's no index-based access with lists, so I can't say give me list element 1. It doesn't work that way. They're implemented with linked lists under the hood, I think, and so they're very fast for like filtering, mapping, reassigning stuff. There are also arrays, and arrays give you index-based access, but they're not as fast for some of the common patterns like filtering and mapping that we're going to see in Elm. So generally, you're going to reach for a list before you reach for an array, and the arrays, if you specifically need to access like the 10th element of this thing or something like that. Finally, we have records. Records are a lot like JavaScript objects. Java objects. Oh. I almost called JavaScript Java at a JavaScript meetup. Never invited back. So So they're a lot like JavaScript objects, except of course because we're in Elm and everything's immutable, records are immutable, you can't update the fields. You also cannot you can't ask for a field that doesn't exist. So if I say that my record is X and Y, and I try to say like record Z, Elm is going to tell me that I can't do that. It's not going to compile. It won't run my application. There's also, as the flip side of that, it's impossible to get an undefined or null value. You can't actually say like X is equal to null or undefined in a record because Elm does not have null and undefined, which is part of why you don't get undefined is not a function, and how you avoid those runtime exceptions. I don't want to talk too much in depth about how it avoids that, but the really short version is that there's a type in Elm that can either be no value or it can be some value, and Elm will make sure that if you have a type or a thing of that type, which is called maybe, you handle both of those cases. So it's impossible in Elm to get by just handling the case where you have a value. You have to think about, I'm not guaranteed to have a value when I'm running this function, and you have to cover that. And we'll talk about more about how the compiler helps you cover those cases in a little bit. Any questions on records or lists or tuples?
I've got a quick one about tuples, if that's
Yes.
all right. So when you're accessing a tuple, right? So in that case, can you do the trick? I know this is possible in Python, and I believe in ES 2015, where you take a tuple and you try to pull out the distinct parts of it. to
Yes,
assign them.
yes. So the question is, can we pull stuff out and assign them to new values, right?
Yeah.
This is like destructuring. It's called a lot. You can do something called pattern matching. I know. I don't know if there's destructuring specifically, but I can say we'll see case expressions in a little bit. But I can say if I have a tuple and I can't say the syntax. I'll show you in a little bit when we go over to like code. I'll type one out.
Sorry.
No, it's a great question. Cool. So let's talk about functions because it's a functional programming language, right? So this is how you might define a function to say hello to someone in JavaScript. So we have a name for our function called say hello that we can use to call it later. We have a parameter to it called subject, and we're returning some string concatenated hello subject exclamation point. So that's what it looks like in JavaScript. This is what it looks like in Elm. So the first thing you'll notice is the function name, then the arguments without parentheses. And also if we had multiple arguments, there wouldn't be commas between them, just spaces. And then the equal means that we're moving from the function definition to the function body. And you also notice there's no return because in Elm, everything is an expression. We'll talk a little bit more about that in a bit, but basically what it means is that everything is boils down to a value. And so the string concatenation is a value. So you don't need to ever write the return keyword. There's no return in Elm. Yes, question?
One thing I noticed, there's no type on the argument. That just strikes me as...
Yes, okay. That's a good question. So the question is, there's no type on the Elm stuff. We don't see any types there. And we'll talk about this in a little bit. It's like I should get a t-shirt. So you don't have to always write types. The Elm compiler can figure out, based on how you're using different things, what types they probably have, and then if it can't figure it out, it'll ask you about it. And then you can write what's called a type annotation to say that say hello is a function that takes a string and returns a string. And we'll look at type annotations in a little bit. Thank you, great question.
So white space matters.
Does it do type coercion automatically? So if I pass it a number,
No.
or would that be an error?
No, that would be an error. You can't say, well actually, so you could define a union type, which we'll talk about. So you could say that I have a type number that can either be an int or a float, and then you'd have to, in your function, say, if the case of the thing that we're dealing with is an int, then do this, and if it's float, do that. So you kind of can. It's not super elegant, and there's probably better ways to solve your problem if you ever get to that point where you're like, I need to do this. Does that answer the question? Okay. Question?
Is this indentation specific or?
It's not Python. Like it's not super strict about whitespace. The community convention is 4-space indentation and then 2 lines between like top level declarations. There's actually a tool called Elm Format that you can run on your code and it'll just like transform it into the like community blessed version of Elm code.
Does that work with Office?
I think Elm Formats actually implements it as an Excel formula. So yeah. Yeah, okay. So that's defining functions, and we all know what calling a function looks like in JavaScript. So say hello, parentheses, pass it the argument. In Elm, it looks a little bit different. We don't have parentheses. So again, we just don't have parentheses. And again, if we had multiple arguments to this function, no commas, just spaces. And also important to note, neither of these do anything. These code examples I have, they're just, they evaluate to a value, but they don't like have side effects or anything. Yeah. So here's a question for you all. Hopefully this is large enough that you can see. Can everyone read this? Okay. This is probably the smallest my code gets in the presentation and like the most important for you to like scrutinize. So can you see a problem here is the question. What?
There's no else case?
Yeah, so there's no default. We're not handling the case where action isn't tap or poke, right? So you could write code like this, and maybe someone comes along and adds an action to your Redux system, and the type isn't one of these types. And you start getting an undefined because nothing's being returned explicitly, and so you'll get that the implicit like undefined return. Yeah, the other problem is there are no semicolons, but yeah, that's another talk. So this is what it looks like in Elm. So again, we've got our function name, we've got our parameter, and the equal sign. That means we're moving on to the actual body of the function. And then we see this case expression. It's very similar to the switch statement in JavaScript, except for the whole thing boils down to one value. So when you say case action of tap, if action is a tap, the whole case expression returns that string you tapped. And if it's a poke, returns you poked. Anyone see any problems with this? Trick question. The Elm compiler, if there are other possible values of action, it'll tell you about it. And so there's nothing wrong with this code. There is a special case. Let's say we have like 20 possible different types that action could be. There is a special underscore arrow you can use to like handle all the other things. But you have to be careful with that, because then if you add something that you will care about, then you've got to like make sure that your functions aren't like silently. I don't know. Compiler can't figure out everything. I see 3 questions, so we'll just go in like nearest in order.
So I guess I'm missing the idea here, but you said the compiler will catch it. Will it just break when you compile?
Yes. So your application won't compile.
So it is terrible.
Okay. So
yeah. But it
So if action is only tap or poke, if those are the only 2 possible values, this is great. This is fine, because your program will compile. Elm won't have an issue with it because there's nothing else that it could be that could break this, right? And then as soon as we add a different action, Elm will say, hey, there's this function over here that you may have forgotten about that doesn't handle this, so you need to update it. Yes, question.
So in the JavaScript version, you were passing in a string, and
Yep.
here you are not passing in a string. What are you passing in?
So we'll talk about like what union types are. It's kind of this nebulous value that's not really a thing, like a string or an int. It's not backed by any of those. It's just a type. I don't know how else to put that. What?
Or tap and poke types?
Yes, tap and poke. So in this case, tap and poke. I haven't shown you what a union type definition looks like, but tap and poke are 2 possible values that this action type could have. Where's the next question? There.
How do you stack cases?
Stack cases. So like a nested case expression?
Like tap and poke both do the same thing.
Oh, yeah. So there isn't that in Elm. If you had like 2 different things that need to do the same thing, you could define a function inside this function and then just use that in both places, I think might be the way to do it. I'm not an expert. Like I don't have 55,000 lines of production Elm code, right? So I don't know all these things, but yeah, I would define a function and use that in both places. Yes, one more.
For this particular code, would Elm be able to figure out what type of action is? Because action's just a parameter, right?
Yes. Yep. And so the answer to that, the question is, would Elm be able to figure out what kind of thing action is to know that it could be a tap or a poke, and how it does that? And the way that it does that is based on how you use this function in other places in your application. So if Elm sees that you're passing this an action type that can either be a tap or a poke or a bop, it'll say, hey, you've got this function over here that looks like it's taking an action based on what it's like expecting it to be, and it will tell you that you're missing one. Any other questions?
Can you use deconstruction in there in those cases too?
Deconstruction.
So let's say you have a list and you want to get the head and the tail out.
Yes, yes. So pattern matching, which is like a whole nother topic.
Okay.
You can say, I'll show you that. Remind me to show you like what getting the first thing in a list and the rest of it will look like. Yeah, okay. Any other questions before we move on? All right. So I mentioned that in Elm, building your UI is a tree of functions. This is what it would look like to have a button. So in this case, there's an HTML package in Elm. It has a function called button, and the general, the signature of these is you have a function, it takes a list of attributes, and then it takes a list of children. In this case, we've got an onClick attribute, which is a special Elm thing that means when this is clicked, fire this message. We'll talk about messages when we get to the Elm architecture. And then the only child of this button is a text node, click me. If you're wondering what DOM node text maps to, it doesn't. It's like actually a text node. It's not a div or a span or something like you'd have in React. So it's actually just going to be like a button with the text click me in it, not a span or anything. Any other questions? So I'm going to assume that most of us are building UIs that are more complicated than this. So you start building up trees. So you see we have a div, and again it's got a list of attributes. So we've got the class card, and then it's got a list of children. And you'll notice that what I just told you about taking a list of attributes and a list of children doesn't seem to be acknowledged here. Profile pic just takes a user ID. And this is kind of how you would define a custom component in React. You just define a function, and in this case it takes whatever type user ID is, if it's a string or an integer or whatever it is, and that will return some HTML that you can add to the children of your card that takes the user. Along those lines, this whole element is a function that takes some type, in this case whatever a user is, probably a record, and returns some HTML. And so you could render a list of these by mapping your list of users over this function, and now you have a list of that UI element, if that makes sense. And then we've just brought our button into this example. But this is the same code that we saw earlier with the JSX example, just in Elm. Questions?
Is a poke user ID a function?
Yes, so kind of. So a union type, you can have possible values, and those values can also have associated data. And so in this case, poke, when that goes through, whenever I have a poke action, I want to know who got poked. And so I could probably define this as like poke int. And then what you're doing when you define a union type that has associated data, it also, like Elm gives you a function with the same name that you can call, and that is like the packaged up message with the data, if that makes sense. Other questions?
So, all right. So the profile pic. Okay. So the button is inside the div. What is the hierarchy here?
Yeah. So something that might be confusing, and this is like an Elm community thing where they decided that the commas look cool if they're at the same level as like the first bracket. Some people really don't like the way this looks. I was a little skeptical at first and started using it, and especially with Elm format where it like lines that all up for you. It's not a hassle, and it ends up being kind of nice because you'll notice if you miss a comma, that kind of thing. So I want to get that out of the way before we like really get to your question, which was like the profile picture and the button. Like those are just children of the div.
Okay.
Yep, and they're siblings.
Sure.
Anything else? All right.
Well, you could probably talk about this at any point. Starting to get curious now. What tools do you use to build this while you're working on it? We'll get to that in a second.
We're going to get to it in a bit. So, and actually, you're in luck. So, we're going to switch over here.
At least 2 seconds, but okay.
Okay. So in this case, the tool that I'm using is called Create Elm App. If you've heard of Create React App, it was inspired by that. And what it is a tool that lets you say, create Elm App JSMN. And it builds something for you that has a Webpack config and some other things that do hot reloading and all this fun stuff. But it hides that from you, and so you just like start writing your Elm code. So if we look at like what that gives us, this is literally just the result of me running create React app or create Elm app JSMN-Elm. So we have a source directory.
It's off the screen.
It's off the screen.
Make it big.
Check your over-understand settings.
Oh yeah, 50 degrees. They need overscan.
I don't know.
I guess I'll just leave this drawer open while I work on the code. So we've pushed it in. You can see it. Are the other TVs good? Is it just this one? They're all cut off.
If you
Okay.
want to fix it, go to System Preferences, Display, and then there's a
Brandon.
Yep.
What's going on here, man?
I'm trying.
Just a second.
Just kidding.
It's not letting you change it. It's that underscan bar grayed out. So I don't know why it's not letting you.
Scale. Click scale.
Scale. Check the track.js log.
That'll do it.
Yeah. All right.
All right, we're back.
Brandon, are we still recording?
We are still recording, but
P90.
I will, yes.
Okay.
We survived.
So can everyone see well enough?
Yep.
So what create Elm app has given me is a favicon, an index HTML file, a JS file, and all that does is like import our Elm app and attach it to the DOM so that we can run it. There's a CSS file which is like really empty, and I've added just a couple styles. And then there's the main Elm file, which is what we really care about. There's also an Elm package JSON, which is, if you're familiar with NPM, you've used package JSON files, very similar. And a README that tells you like how to do stuff with the app that it just gave you. There's also this Elm stuff directory, which holds all the packages that you install. It's kind of like a node modules folder. Yeah. So what we really care about right now is this file, which is main.elm. So again, we've got main in every Elm application. We've also probably got main.elm. That's fairly conventional, but I don't think it's enforced. You could probably name your app something else. So what we want to do is define that function that we saw before. I'm going to take the type annotation off that because we haven't talked about type annotations yet, and I'm not going to add type annotations to what I type. So yeah, so we're going to define that say hello function, and it takes a subject, and it returns hello. Another thing, you probably noticed that I typed plus twice, and that's not because I'm like bad at typing or something. In Elm, plus is used for math with numbers, and plus plus is for string concatenation. So we'll add our subject, and then we'll add an exclamation point. And one of the other things that create Elm app does is whenever you change your code, it updates your application and reloads it. Nothing's broken. We're still seeing hello world, so it's probably okay. And then we're just going to replace this with say hello JSMN. Oh, you know what? I stopped the create Elm app, the server. I was going to show you how to start it. So plan that. And so I was going to switch over to this tab to show you the compile message, but I'm already here. So this is kind of what a compiler message looks like. It lost the color that you'd normally see if you ran Elm make, which is like the actual Elm compiler directly. Some of these things that have colors that make it maybe easier to scan. But what it's telling us is that the first argument to the function text, remember everything in Elm, like a div, they're all functions. So the first argument that we're passing in, say hello, isn't what it expected it to be. Text is defined that it takes a string and returns some HTML, but what it's seeing is that text is getting say hello as a parameter, which is a function that takes a string and returns a string. So we're getting a mismatch here. And there's a clue down here. Maybe you forgot some parentheses, and that's what we forgot. So the trick is that we need to disambiguate for the Elm compiler that we want to actually call say hello with JSMN and then call text with the result of that. So if we compile this, we're back. Cool. That's the code for now. So we're going to bounce back into some slides.
So Webpack then?
What?
Webpack?
Create Elm app uses Webpack as like behind the scenes to do the hot reloading, yeah. Yep.
Question.
Yes.
So where you call that function in, for example, so this is a component-based thingamajigger, right?
Yeah.
So you could use something like a partial, if you will, like where you can link to, I mean, how?
So you define a function. So the question is like, are there things like partials?
Yeah, like what if you've got?
Yeah. So like a partial is kind of like a component you might define. So I can say like, I want to render a button with this text, that kind of thing. In Elm, you just create a function that takes some parameters and returns some HTML. All right, so we're going to talk about types in a little bit more detail. I'm going to try to speed things up because I feel like not going fast enough.
No, you got it.
We're good? Okay. If we hadn't had that display mishap, it'd be totally fine. Just like, I don't know. So everything in Elm has a type. We have a type system, and in that, everything that lives inside of it has a kind of thing that it is. So in this case, when we say event equals the string JSMN, you'll notice on top of that, we have that thing that I talked about earlier that's called a type annotation. So this is telling the Elm compiler that what we intended, not necessarily, this isn't the same as saying, Elm compiler, this is a string, and just listen to me, trust me. The Elm compiler will check this, but this is a way of letting the Elm compiler know what you intended. And then if those ever don't match up, which probably isn't going to happen in this example, but if you have something more complicated, and suddenly your type annotation doesn't match what you actually have, the Elm compiler will let you know. You can read the colon as has the type or is of type. So you can read that whole thing as event is of type string or has the type string. We'll look at some more complicated types, and we'll meet our union type on the next slide. But we're going to talk about type aliases first. A type alias is really what it sounds like. It's a way to give a new name to a type. There's a really simple one up top where we're just saying that instead of calling an int always, I sometimes want to call it an ID, but it's really just an int. And so we can define type alias ID equals int, and then anywhere that we want to use an int, but it makes more sense semantically, like in a domain level, to call it an ID, we can call it an ID. We can also create type aliases for a record. So in this case, we've got a type alias user, and we're saying that anytime we say user, what we really mean is a record, like an object, that has an ID of type ID and a name of type string. There's probably in a real application going to be more things in there, but that's like, enough to get us going. So if you look at our example from earlier, I've added a type annotation, which says that card is of type, and the arrow you can read as, just follow me along here. So card is of type function that takes user and returns HTML that produces messages. And we're going to worry about the HTML that produces messages part when we get to the Elm architecture. But basically, it's that associated data thing that I talked about where an HTML type of thing can have messages attached to it, like kinds of things that it can send back up, the actions that it can produce. So type aliases, not type aliases, sorry, union types. So up at the top, we've got type action, and that can equal either tap or poke. Again, I'm using some like community Elm format sanctioned style here. You could also write that out on one line. If you don't have a ton of types, you could just say type action equals tap vertical bar poke. This is just kind of a convention. You just generally always list them out this way. And then we've added a type annotation to action to message. And again, you don't need type annotations, but it's helpful to have them both for developers and the Elm compiler. As a developer, I can say, oh, action to message takes an action, returns a string. And I don't have to read the implementation to figure out what kind of thing to expect. Yeah, so if we added type equals action or poke or, I don't know, slap, Elm would tell us that now this thing that takes an action isn't accounting for all the possible values. Questions? Yes?
Do you have to define the type right above the method that you're using it?
No, and we're not going to talk about modules today and like importing things from other modules, but Elm does have a module system. You can expose that. You could have a file if it made sense to architect it this way to you. You could have a types file that defined all the types and exposed them, and then other things could import those types. You could define this action alongside some code that normally uses it, and then maybe somewhere else you want to import it and also use it. So you have a lot of flexibility there. Another question?
If you define slap into action, so type is
yep.
action tap poke slap, but but you didn't implement slap in your action to message, would that be a compiler error?
It absolutely would. Yep. So the question is just if we add an action, would the compiler tell us we're not handling it? And absolutely yes. And your users will never get an error because we didn't handle them slapping each other, which they probably shouldn't do, but we'll allow it.
So on the same note, if we just call slap without adding it to action, what will happen then?
Yes. So the question is, can we just call slap without adding it to action?
Or will it break?
Yeah. And so the answer is that it's hard to say like what a type is because it's a type of thing. But you can have a type that has an associated piece of data, and in that case you can call it like a function, but you're really just getting another type that has some data along with it. So maybe I don't fully understand your question. I'm sorry.
I think he's saying if you add a third case to the bottom for slap, but you haven't added slap to the action type of.
Oh, yeah. Is that what you're asking? So if I add slap down here but don't add it to my action type?
Well, I was thinking more you pass in slap as your input to the function.
Oh, okay. Without adding it to the top?
Right.
So that's not possible because we're saying that we're expecting an action, and if we haven't added it as a possible type of action, we can't do that because.
But how does it tell you that? Does the compiler tell you that? Does it tell you in the IDE?
It will tell you, like the compiler will tell you. I haven't seen that message specifically because I haven't tried that thing. In general, Elm messages, like the compiler messages, are very helpful.
It would be similar to if you had a function that took a string and you tried to pass in a number when you were implementing it.
Yeah.
It would fail. You get essentially the same message.
Oh,
The type of item you pass in is the wrong type. Right. Slap is not an action.
Yes.
Because you haven't defined it in an action.
Yes. Thank you.
Just like a number is not a string.
Yeah.
Absolutely. Yep.
Thank you.
Okay. So, any other questions on types before we move on to the Elm architecture, which is super exciting? Great. Okay. So the Elm architecture, it looks like this. So we saw that diagram earlier where actions go into the dispatcher, go into the store, go into views, which produce actions that go back into the dispatcher. So in Elm, things are basically the same, but they're called slightly different things. We have an update function, we have a view function, and then there's this thing called the Elm runtime. And the entire time that your application is running, there's also something running alongside of it called the Elm runtime. And the idea is that if you say, this is what my HTML should look like, the Elm runtime is where that virtual DOM implementation lives. So it says like, okay, this is what you want it to look like. I know what the DOM looks like. I can update that efficiently. We'll talk about like making HTTP requests in a little bit, but that's also where those actually happen is the Elm runtime. You don't see the runtime directly. It's just, it runs your application for you.
How much size does that add to your download?
So that's a good question. So the question is like how much size having the runtime adds to your application. Elm is still fairly new, and they haven't really optimized for like the size of the final file that you get yet. But from what I've heard, it's comparable to something like React. So it's not like super small, but it's also not like a giant, huge file. I think question back here first, and then I'll get to you.
Oh, I just wanted to ask if the runtime could be like a separate file from the actual program, so when the user loaded two different
Sure.
apps, they
Yes.
have to download the runtime code?
Yeah. Okay. So the question is, can we do code splitting and just have the Elm runtime included once, and then include like this page's Elm stuff on this page and this page's Elm stuff on the other page? I don't know the answer to that, but I think so. The current version of Elm is 0.17. 0.18, the big feature there is this debugging stuff, and specifically like time traveling debugging stuff that's really cool, but we're not going to talk about it today, so you should totally Google it after this, or Bing it or whatever. But what they've sort of slated in the roadmap is that in the future, probably the next release, maybe, after the next release, which is coming out, I think, really soon, they're going to start thinking about like, well, lots of people are using big Elm apps in production. We should probably start optimizing this stuff. So I'm sure it's coming. Question?
Go ahead.
All right, good, okay. So the Elm architecture, we talked about there's an update function and a view function. What each of those does, update is passed a message, which is like an action in Flux, which is just like this thing happened in your application. And then it's passed to the current state. It decides what to do to the state with that message, and then returns a new state. That state gets sent to the Elm runtime so that the next time you call, or a message is sent and you need to update, you have the new state. So the Elm runtime gets your new model, and then your new model also gets passed to your view function. and that produces HTML. And then your HTML gets passed to the Elm runtime, and the Elm runtime says, okay, I'll modify the DOM to fit that. And then when things are clicked, the Elm runtime sends a message back into your application. That make sense? Cool. This actually, there wasn't an Elm runtime for the entire time that there's been Elm. This actually arose from Evan Chaplicki seeing like, oh, a lot of people that are using Elm are doing like very similar things. Maybe there's something to this. And so they actually just built it in. So you don't have to, if you've used like Redux, especially I think like, it's like, oh, I need Redux and I need to do async stuff. So I need like Redux Thunk or Redux Saga and I need like these packages and all this stuff. This is all just built in. So you can just HTML that app, which we'll see in a second. Like literally a second. Okay. Bear with me while I do some Git. That undefined, I saw that last 2 nights ago and I freaked out. I was like, this shouldn't be possible. It's just the hot reloading server because I changed the entire code base. It's not actually like undefined value in my Elm system. Yeah, I was like, I'm giving a talk on Elm in 2 days and it just did something it's never supposed to do. What's going on? Yeah, okay. So I have set up some type aliases, our model, our update function, our view function, and our program. I'll show you each of these things briefly, and then what we're going to do is just add some interactivity. Okay. So we've got a type alias. Our model is just a record with a greeting string. This is our actual model that we're going to start with. So our greeting is just hello JSMN. We've got a type of message. Message doesn't have to be called message. This is just a convention similar to how like things that happen in Flux and Redux are called actions. In Elm they're called messages. And right now we just have nothing. So the only thing that can happen in our application is nothing happened. So we have an update function, and because nothing can ever happen, I don't have a case statement in here yet. I just have, it's always like the same thing that it was because nothing happened, so nothing changed. We'll change that in a minute. And finally we have our view function that takes our model and then returns a div with our greeting.
I want to read the types on the update method.
Yes, okay.
It takes message, returns a model, which returns another model?
Yes, so everything in Elm, if you're familiar with partial application or currying, everything is curried automatically. So the way that that actually works, and you don't have to think about this like right now to just absorb all this, but update is actually a function that takes a message and returns a function that takes a model that returns a model, right? So if you call update with just a message, what you get back is a function that takes a model and returns a model. Does that make sense? Kind of like enough to keep moving? Okay, great.
Are you defining the update that happens in that visual sort of flow you showed earlier?
Yes.
Do you have to define update?
So the update function?
That was kind of part of the
Yeah. So the update function is where we decide, like, based on the message that came in, we have our current model. The changes that we make, we just return an entire model that has the changes that we want.
So just sort of, I've done some React type of stuff, Redux stuff. Is this like your kind of reproducer?
Yes. Yep. So in Redux, this is like a reducer.
And returns a new version of state?
Yes, absolutely. Yep. So the question is, like, is this like the reducers in Redux if you've used that? And yes, very, very. These reducers in Redux are like inspired by this part of the Elm architecture. And then finally, we define our beginner program. And what this syntax means is that we're passing a record to beginner program. Again, we don't need parentheses, so it's just going to take the next thing that it sees. And again, we've got commas in the beginning of the lines because that's what we do in Elm.
Does that second line have to be indented to be like a second argument as opposed to a second?
This one?
Yeah.
Oh. So Elm format is pushing it in for me, but if I didn't have Elm format turned on, it would still compile.
It doesn't have to be formatted this way?
It doesn't have to be, no. This is like, again, just like community has decided that this is like really readable and nice and we like this. And you don't have to use Elm format. Yeah. Okay. And this program never always makes me laugh. And the type main in a beginner program or a program that we'll see later, which is like a beginner program but with more capabilities. What this is saying is that never is the flags, and it's possible in Elm to pass in some stuff at the beginning, some like data that our application might need to get started. And that type, we could maybe say that when we start an application, we need an int, and that would be the type. But in this case, beginner program doesn't take flags, so we just have a program and a never, which is just a special type that means like this should never happen. So yeah. Okay, so we want to add an exclamation point to this greeting every time we click somewhere in the page, because that seems like a good thing to do. So the first thing we're going to do is import these HTML events. In Elm, you've got like the HTML module. It's got HTML.attributes if you want to use like style and class. It's got HTML.events if you want to use event generators, mouse over, all that stuff. And then we're exposing. Again, I said we're not going to talk about modules and how that all works, but in general, like we could just say that all we want to expose from this is the onClick. And if that's all we ever use, we're good. And the reason you might want to do that is if you ever have like two things that expose something with the same name, then you want to avoid collisions. Like you can't just import everything from both of those because the Elm compiler won't know which one you're talking about.
Does the compiler, when it compiles this to JavaScript, only include code from the core module that you need based on the things you're exposing? If you only expose onClick, does it really less code than everything?
So the question is, if I only pull in onClick, is that all that it's going to put in my final like bundled file? I can't answer that like super confidently, but I think what it actually does is figure out what you're actually using, not even what you what you say I want to use from this package. It'll figure out what you're actually using and just include that. I think. Don't quote me on that.
Just expose everything and then
Yeah.
just use.
Yep. In general, I will just like expose all the things. So.
Question about.
Yes.
This is a very loaded question. Obviously, you didn't write Elm, but why did they decide to go away from, say, some JavaScript standards that were coming about and they're writing in a language that will transpile more to JavaScript?
So the question is
why
like.
Why not import star from
right.
as opposed to thing exposing?
So I think the answer is the timeline. Like this was created in like 2012, and so they probably added a module system before the like ES6 import
They based
syntax
it off
was
of
defined.
previous languages. It seems like more based off previous languages.
Yeah, I think Evan was like a big Haskell guy, and so this might be inspired by Haskell. I don't know. I haven't used Haskell, but a lot of the syntax is pretty similar to Haskell. Yeah. Okay. So in our view function, the first thing we're going to do is say, when you click this, I want to fire a clicked message. We don't have a clicked message, so we're going to go add it. And actually, maybe we'll just see what happens if we try to do that. 1 second. I'm going to make this readable. So create Elm app will also put these errors in your Chrome console so you can see them, or whatever browser you're using. And so it's saying we can't find the variable clicked. So what we'll do is just add this as a possible message. I don't know why that's indented like that automatically. So we're good. So this is like a valid thing. This is a valid program. We're never using anything incorrectly anymore. But we're also not using clicked.
Sorry about that.
Thank you. Thank you.
That is one mistake I cannot take responsibility for.
I forgot to prepare for that. That's my bad. I should have had something in this section of the talk.
In the case statement, I believe.
Yes. Yep. I didn't handle that possible. Yeah. Yep. All right. So while we were all having fun, there was a question asked about what the MSG after HTML means. So I wanted to actually just talk about this really quick. So in the the type annotation for view, what we're saying is that so view is a function that takes a model and returns HTML that has the ability to produce messages. I'm not sure exactly all the details of like how that actually works, but we're just telling the Elm compiler and the Elm runtime that this HTML that we just gave it can produce messages of this type. So that MSG is talking about this type. And so we're just saying that things in this HTML can happen that send this kind of message back through our system.
Is it a tuple? You're returning a tuple?
it's not a tuple. It's a type declaration that means that we've got HTML that has associated messages. So it's so yeah. So like the type for a list of integers looks like this. If that helps clarify anything. So like we say we have a list of integers by saying list int. We just have a list that contains ints. In the same way, we have HTML that can produce messages. There's no like one thing that it means. It can mean different things in different contexts.
So if you didn't have the onClick, you would not type the message?
If we didn't have, well, you don't have to have the explicit type, the capital MSG, but you do have to have something. You have to tell the compiler, like,
Event or something like that?
no, so
Is it a type or a name?
beginner program is expecting Vue to be a certain type of function, like it expects it to take a model and return HTML that has something associated with it. If you don't have a message type and you never produce messages, it's valid to do this. And that lowercase thing is a type variable, which just means that like it's no one thing. It could mean different things in different contexts. You might have a function like if I were to say like the map function that takes a list of things and returns a new list of things, I don't have to say that it's like necessarily an int or something. Yeah. Yep. Yeah. But in this case, because we're explicitly saying, so in this case, because we're saying that on click we're going to produce clicked messages, we have to say that HTML has like this message type that we've defined. That's the kind of thing that it can produce.
Because HTML is defined like a collection, like a list.
It's similar, yeah. So it's
always there's something inside it.
Yep, yes.
Oh.
Question.
So the way in which ints was associated with list is different than the way that message is associated with HTML.
Yep.
Are you able to define how data is associated, or is that just part of like the built-in package? Like you have these associations and just go use them?
That's a good question that I can't think of an answer to right now.
Okay.
Oh, no, actually I kind of do know the answer. So we could say that maybe we can click different things in our system and they all have an ID associated with them and those are represented by integers. So I can say that clicked can have an int associated with it. And then if I try to compile this, it won't work because it's expecting to see a message. And what it's actually getting here is a function that takes an int and produces a message. So again, when you declare that a type, a possible value of a union type can have associated data, it also defines a function with that same name that takes that type of data and returns the actual like full thing, like type. And so in this case, because we've said that it has an int associated, it's telling us that it looks like we're trying to return HTML that has messages of functions that take integers that produce messages, which is like not valid. And again, this is blowing up because the type annotation for Vue doesn't match its definition. We're saying that HTML message, and it's actually this. So maybe we could fix this by saying that, maybe we could fix it like that. And then the problem is going to be that beginner program is expecting Vue to take a model and return HTML that produces messages, and that's not what we have. So there's like different levels where this is expected to be HTML with messages associated with it. So the way that we could solve this, like we saw earlier with the poke example, is if this is like thing 42. Now we're okay. Questions?
I have a question with that notation you had earlier, where you had the what do you call it, type declaration?
Type annotation?
Above. Can you bring that back above the Vue?
Oh yeah. So Vue in the Elm architecture is a function that takes a message, it takes a model, and it returns. No. I'm sorry. I'm thinking about update. Vue takes a model and returns HTML that produces messages.
Right. So I think I just want to ask if I'm maybe thinking about this in a way that could be accurate, where the Vue function takes a model and returns HTML, but like sort of asynchronously or around events could at some point spit out a message because you clicked something. You know what I mean? Like, because you have the update function which takes a message, returns a function which returns a model.
Yeah.
The notations are weird to me, but it is sort of like this function takes a model, returns HTML right away, but at some point might fire a message because you clicked.
Yep.
Like asynchronously.
Okay, I think I understand your question, and I'm going to repeat it. So the question, I think, is that in the case of model, we're saying that it's going to take a model, or a message, sorry. In the case of update, we take a message, we take a model, and we return a new model, like, right away. That all happens synchronously. But in the case of view, we have a function that takes a model and returns an HTML chunk of HTML that can produce messages. But it doesn't mean that we've already produced a message just by like running that function. It just means that in the future, it's possible that this HTML could produce an action of this type or a message of this type. Does that make sense?
Is that what that notation means?
Yes. Yep. So I'm going to remove the integer part of this, and you can see how the Elm compiler is going to like guide me along and say that now that's broken, and so I just go fix this, and now we're good again. Okay. And so finally, we're just going to handle the click in our update function. So we're going to say case message of clicked, return our model, and this will compile. No, it won't, because we don't have a branch for every possibility. So what we need to do is handle the case where this could be nothing, and we'll still just return our model. Okay, so Elm is happy. We're not doing anything that's illegal, but we're also not doing what we wanted it to do. And this is really like the error that you might find in your program, or like a bug, is you forgot to do the thing that you were supposed to do. So like your behavior's not quite right, and Elm can't help you there, but it totally will help you out if you like forgot to handle the case where nothing happened. Something that we didn't talk about, I said that we can't update fields and records, so like how are we going to change greeting in our model? And the answer is, well, we could return a new record that has a greeting field that is equal to our model's greeting field plus an exclamation point. Can anyone think of a problem if I start doing this? So Elm is happy. Our application is doing the thing that we expected it to do. But can anyone think of where this might break down? If we're saying just...
Model is really complicated.
Yes, exactly. So as soon as we start adding things to our model, the type system is going to say, hey, wait a minute. You're just returning, in this case, something with a greeting, but we also are supposed to have this other value. And so there's a syntax called record update syntax, where we can say start with model and then do these modifications to it. And so that will keep everything else and just modify the things that you tell it to do. And you can do multiple like modifications. So say we had something else in here. We could also say that x is now 14. Yeah, and so this also works. Oh, you know what? Yep, I did. I don't know where that went. So that will also come out and still work. Okay, questions. We're going to... Brandon, how are we doing in time?
Doing fine. We're good.
Okay. I'm doing fine. We're good.
You got this, Mike.
Okay.
So can I create, do I have to have a single update function? Can I create like a component?
Yeah. Okay. So the question is, do we have to have like one single update function? And the answer is yes, but we can call other update functions from this main update function, which seems kind of weird. But in the end, like your entire application is kind of this tree structure where like maybe we updated, I'm not going to show this today because it's kind of like complicated to set up, but and I just can't like type it out right now. But basically, yeah, if you had like a widget that managed its own state kind of, it doesn't actually manage its own state. Your model at the top level holds onto its state, and then when it gets updated, it gives it its state and the message that happened, and then gets the new state back and puts it back, if that makes sense. We're just like nesting things. And it's not as bad as it sounds. Yeah.
Does the top level update have to know what messages go to which subcomponents? Or is
So that's a good question. I'm going to do something that I'm not going to try to compile because it's not going to work, but let's say we had a button module and we want to expose, no, I'm just going to leave it as button. If we import button, maybe this also, the type of message could be a clicked, I'm forgetting how you write this. But button can define its own like message type, and then you can say that like a possible thing that could happen in my application is a button's message type happened, and so I like in my update function would delegate the button's update function, and do you understand how that works enough? Okay, I'm sorry, I can't like type it up. I would love to show you, but yeah.
Types that would all be forwarded to the button.
Yes, yep, and it's all just like the module system. So like you can have a type in there, and then you can import it and do all that stuff. I'm gonna try to fly through a more advanced program. So you can get pretty far with a beginner program like that, but the problem is that beginner programs are like self-contained. So the only thing that can happen is our HTML produces messages, which updates our model or our state, and then updates the views and so on. So it's this closed loop. What if we want to do things like HTTP requests? What if we want to do, interact with the outside world? We want to use a WebSocket, that kind of thing. The answer is app.program. Again, you can get pretty far with beginner program. It's not like, if you're a beginner, you need to use beginner program. But yeah, if you want to do more complicated stuff, you need to use something called effects. So this, what I called the Elm architecture before is really how like beginner program works. And we can make some modifications to it that let us interact with the outside world. So the first one is that, I'm going to point on this screen. I guess, can I use my, no, I can't use my mouse. Okay, so the first thing to note is that update returns a model and a command. And so a command is a thing that says, I want to do this. It's not an actual, like, it doesn't make an HTTP request, but it says, like, I want to get something from the server at this address. There are lots of different possible commands. HTTP requests are one of them. Your view function still just gets a model and returns HTML, but your update function can now return a thing that it wants to do. So if, as a result of a message coming in, you want to do something, you can tell the Elm runtime, I want to do this thing. And just like we saw, the HTML has a message type associated with it. Command also has a message type associated with it. And so when the command, the Elm runtime says, hey, that thing that you asked for, I did it and it's done. Here's the message that you told me to send you when I finish the thing. And there's another way to get things in from the outside world, which are called subscriptions. So if you see on the left there, there's sub and an arrow pointing in. And then subscriptions, you can say, when someone resizes the window, I want to know about it. And Elm will pass that into you using the message type that you told it to. I'm going to show you all this, so I'm going to keep moving. So this is the difference in how you define the two. You'll notice that app program doesn't take a model anymore. It takes an init value, which is a tuple of a model, and optionally a command that we want to run right away when we start our application. Often you won't want to run anything right away, and you can use a special value called command.none to just say like, I got a model, I don't need to do anything yet, but that's init. And then subscriptions, you can return like anything from the outside world that you want to listen to. And lastly, update is not, it has a new type, like we talked about. It can return a model and a message, and the way that you do that is with a tuple. So it's the same signature actually, or return type as the init function. It's a model and a command that produces messages, eventually, in a tuple. Again, I mentioned briefly that when you have a command, it doesn't mean that anything's actually happened yet. It's different than a promise. Promises are, also things that may not have happened yet, but might eventually happen. Commands are a little bit different in that all they are is data. It says, hey Elm, I want to do this thing. And then Elm says, all right, I'll do this thing, and then eventually get back to you with the message that you told me to send you. They're useful for like HTTP requests and lots of other things. Yeah, so subscriptions, you pass this to your program when you start it, and it's a function that takes a model. You can read stuff off the model if you want to, and then it returns a subscription that produces messages again. So it's like a command in that when a thing happens, it will send a message into your application. And this is actually, we're going to type this out in a second. We're subscribing to mouse moves. So anytime the mouse moves, and that syntax there is an anonymous function that slash and record XY. We're pattern matching, so we're expecting that mouse moves is going to like call this function that we gave it with a tuple that's, or a record that's got an X field and a Y field, and we're going to use a message type constructor to turn that into a message with data attached to it. And then that message will get sent back into our application. Finally, I'm going to just like blow past ports. Ports are how you interoperate with JavaScript. So if you want to send things to JavaScript, get things back from JavaScript, you use ports. And by defining port to JavaScript, you get a function that returns a command. So in our update function, if the message was say hey, we can call to JavaScript with the string hey, like hello.js. And when we return that from our update function, the Elm runtime will make sure that it passes that to JavaScript. And the way that it does that is when you define your Elm program, when you embed that, you can look at app.ports.toJavaScript and subscribe to any messages that come off that. And inside this function, you can do whatever you want. You can pass it into your own JavaScript thing. You could say you want to use this with a library. Like you've got a library that's written in JavaScript. You really want to use it. How do you use it with an Elm application? You do this. So you can send stuff out, do stuff in the library, and then send it back in, which looks like this. So let's say our application has a type message, and the possible message in our application, there's only one. It's new message. That naming is maybe confusing, but we're not talking about like the Elm architecture message. We just mean like JavaScript sent us a thing. It's saying something to us. And that has a string associated with it. And then we say that port from JavaScript takes a function that turns a string into a message and gives us a subscription that produces messages. And then in our subscription that we pass to the app program, we say from JavaScript to message. And that means that anytime we send something from JavaScript through that port, it will use the new message application, and that's what our update function will see. And this is how you pass stuff in. So again, you do app.ports, and in this case, because we named it from JavaScript, and the two JavaScript from JavaScript are just names that I picked. You can use whatever you want, anything that makes sense, and you just .send, or hey Elm. You can send lists, you can send objects that get transformed into records on the Elm side. It's not just strings that you can pass back and forth. Yeah, that's ports really quickly. That's the quick version of ports. So we're going to jump back into our code example, and we're going to transform our beginner program into a full-fledged program. Okay, so I haven't changed anything. Well, no, that's a lie. I have changed some things. I haven't changed much. I've added an X and Y to our model. We're going to use this to track the mouse position. So we're going to subscribe to the mouse moves and update our model with just the mouse's X and Y. So we're going to define our initial model. The two things that can happen so far are nothing happened and clicked. We've got our update function as it was. We've got some more complicated UI now. We've added an image, and it's positioned absolutely based on the model's X and Y. And we're still using a beginner program, so we're not actually subscribing to mouse moves. We still have our clicked message, but what we want to have happen is that image should follow our mouse around. So we're going to just do this step by step and let the Elm compiler guide us. So it's saying, hey, the argument that you passed in, this record of model update view, is expecting to see init and subscriptions, and it's seeing model, but it's not expecting that. So we'll fix this by first saying that init is just our model and command none. I didn't write a type annotation, but that type is just returns a model and a command message. So now the problem is that we're expecting to see subscriptions, but we're not. And for now, we're just going to say that we're not subscribing to anything just to get this to compile. So subscriptions is equal to, or sorry, so the type of subscriptions, it takes a model and returns a subscription that produces messages. And so to define that, we're going to take a model. Again, that's our function argument. And we're just going to return sub none for now, which is the same thing as command none. It just never does anything. But it'll make Elm happy, and it'll compile. Then we can move on and actually implement our functionality. So this should compile again. No, the update function doesn't have the right type. So now the problem is that our update function should be returning a model and a command that produces messages in a tuple, but it's actually just producing a model. So if we change the type annotation for this, this is what we should be returning. And then we just need to make sure that in each of these cases, we're returning a tuple that contains the model, and we're never going to do anything. This might look like it gets kind of like repetitive, like having to add that to every branch. There are ways to make that less verbose that I'm not going to touch on today. So Elm is compiling our program again because everything is the type that it expects, but we're not listening to our mouse. So we're going to import the mouse module, and it's not going to work because we need a new dependency. In Elm, the mouse package is actually a dependency we need to install. So we use Elm package install elmlang mouse. Another thing in the Elm package registry, everything is namespaced. And so it's elmlang mouse, or like your username mouse. So we can jump back in and save, and it'll recompile. And then we can add our subscription. And actually, before we add the subscription, I'm going to add the message type and update, or the branch in the update function, so that when we add the subscription, it'll just like start working right away, because that's more impressive. So the mouse moved with an int and an int, which will represent our x and y. Elm is going to tell us that we're not handling that case, and it's also telling us that mouse is unused and we should remove it, but we're going to use it in a second, so we'll forget that happened. So we're going to add a mouse moved case, and we're pattern matching here to say that we've got a mouse moved that had an x and a y attached to it, or two ints that we're going to locally in this branch of it call x and y. And then we can say we want to start with our model, and then x is the new x that we got, and y is the new y that we got. And then we'll return command none again. What am I missing? Oh, I didn't hook up the subscription. So what we need to do is actually use that mouse package that we installed. So we say mouse moves, and we give it a function that takes a record of x and y and uses that mouse move constructor to pass data back into our application. And now we have something interactive. Yeah, right? 79 lines of code, and we have this. Yeah, so along those lines, I will say that like it's kind of verbose. Like I've seen some people say like, oh, if I want to do a random number, I have to like use 50 lines of code. It's not really optimized for like building small things like that, but this is, it scales very well. So when you have a lot of code, you're not writing as much code to like handle, I don't know, if that makes sense. It's not as verbose like as you scale. Like you're not going to be having like this much code for each little feature. Does that make sense? Question?
How do you add debug logging?
There's a thing called debug log, and I always forget the syntax. So I'm going to try it and we'll see. But the basic idea is that debug log, if I'm doing this correctly, whatever you pass it, it's going to pass, like, it's going to evaluate to that. So it basically, like, adds some logging. Man, yeah, there's a thing called debug log that you can use to do that. I don't remember the syntax for writing it, unfortunately. The reason I probably don't know how to do that, like, obviously I know how to do console logs in JavaScript because you use those all the time. Generally, I don't find myself like, oh man, I wish I could console log something here, because either the compiler is going to tell me like, oh, you're probably not doing the right thing here, or it's going to be fairly obvious that like I was headed down this path where I'm implementing a feature and I forgot to like get all the way there. So like very rarely am I looking for like, oh, I need a console log. You could also just like render the value out to the DOM or something. But yeah, there is a thing that exists if you want it. How much time do we have? Because I have like a couple things that I can do on top of this example if people want to see it. Otherwise, if we just want to ask questions, at this point I'm like done. So yeah.
Well, are there questions?
Yeah. Yes.
Do you miss JSX?
No. No, I don't. The JSX isn't terrible, but like just writing functions like this is so much easier. Like the syntax is very consistent. It's not like, oh, I have an attribute that's just or pop that's just a string, so I can use quotes here, and then I have a value, so I need to use curly braces and like, I don't know. It's much more consistent in my experience. Like you're always just writing like thing attribute list, children list, and I don't miss JSX. I still write a lot of JSX like in my day job. But yeah.
So if you have a function that has multiple lines of code, it's always the last line that gets returned as the return value?
It's not necessarily the last line, but it's like the last thing that it executes, right? So if you have like a case statement and the first thing gets matched, it's like the last thing in that branch is what's returned, yeah. Question? Testing. Testing is actually really cool. I'm not going to show it today, but there's a library called Elm Test. And one of the fun things that having like this functional pure language gets us is you can do a thing that might be called, you might have heard like property-based testing. Elm calls it fuzz testing. And what it means is I can say I have a function that takes ints and does a thing. And you can write expectations against that. And then you can say, hey, Elm Test, give it like whatever you want. Like just generate a bunch of random stuff, run it like 100 times and see if it ever breaks. And if it ever breaks, it tells you what it passed. It's really, really cool. And you can generate, they call them fuzzers. So you can say like, I have a user fuzzer that like generates random user objects. And you can just say, I have some UI that should always have this property about it. Give it 100 random users and see if it ever breaks down. It's really, really cool. Yeah, other questions? Yes?
You said you didn't have 50,000 lines of Elm code. How much do you have in production?
I don't have any production Elm code. If I had to guess, like the side project that I've kind of been working on, there's a few hundred. It's maybe close to 1,000. It's certainly not 55,000. Yeah. Question? I'm neglecting this side of the room. I'm sorry. I'll look over here next.
Go down first.
Anyone over here? Good? Okay.
No.
There was one over there.
Was there? Oh, way over there.
Have you had a chance to look at ClojureScript ever? Or
Yeah.
Sort of how this compares? I guess it's different because
Yep.
this is strongly typed, whereas a little less. So.
Yeah. So the question is if I've ever used ClojureScript. I have dabbled in ClojureScript, not to the degree that I've used Elm. So like I wrote a book on Clojure and like built some small things, but nothing significant. I generally feel like ClojureScript is a little more flexible. Like I can probably hack on something and get it to do what I want a little faster in ClojureScript, and then Elm is a lot more structured and prescriptive about how you write your applications, but that's probably a good thing in most cases. Yeah, ClojureScript is very, very cool. There's a lot of cool ideas there. Other questions? Yes.
So, how's browser compatibility since you're basically dependent on Elm?
I don't actually know like old IE version. Like any major browser is going to work. I can't give you a number. I'm sorry. Like
You could probably
IE6.
JS from Babel to.
You probably could. You probably could compile it.
Thinking,
You
like,
know.
Like how it handles mouse events. Like, is it going to handle?
Sorry. What?
Whatever the Microsoft Touch events.
Oh, that's a good question.
I mean, it's.
Yeah, I don't know.
It's not just dumb browsers. It's the browsers do lots of different things too.
Yeah. I don't know. I'm sorry. Yeah. Other questions? Yes.
Is it strictly functional?
Yes. So everything in Elm, the question is Elm strictly functional, and if you want to define functional as like I have functions that are always pure. So if I give them the same thing, they always produce the same result. It's functional. If you want to define it as like all the data is immutable and we have pure functions, still functional. I don't actually know like a definition of functional where it doesn't fit, but I would say it's strictly functional. Yeah. Other questions? Yes.
You're
As I'm kind of thinking through this question, maybe it makes sense, but like React sort of strictly defines itself as a UI, like a UI library.
Mm-hmm.
So I don't know. I'm trying to think of what else you would have client side, but is that what Elm says it is, or is it just a functional JavaScript, compiling to JavaScript language, or does it say it's a UI?
So the primary use case, Evan Chiplicki, who designed it, was interning at Google and was like frustrated by some I can't figure out how to do this front end thing, like vertically center this thing, and he's like, we should have better tools for this. And so Elm was designed as like, I need to vertically center stuff, kind of. Yeah. So it was invented because like he felt we didn't have like nice enough tools for doing front-end applications. And so where it started and where it currently is still pretty anchored in like front-end applications. So it's kind of like a Vue library, but it does all the state management stuff too. React is also like a Vue library that does state management stuff too. But yeah, there's a project called Elm Native UI that is like a bridge between Elm and React Native. So you can, it's like a test project right now. It's not like production ready, but again, Elm is really new, and people are like exploring that kind of thing right now. Question?
Is there any talk about compiling Elm to WebAssembly?
Yes. Yes. So the question is there talk about compiling Elm to WebAssembly? And absolutely. So the fact that it compiles to JavaScript right now is just because that's what runs in browsers. When there's WebAssembly and it's widely supported, yeah, absolutely, they'll compile the WebAssembly and you'll have a faster application without changing your Elm code at all. Other questions? Yeah, that's right. So there's an issue with like Elm not having a garbage collector, so it can't use WebAssembly. But they're talking about like how can we solve this? Yes. Anything else?
Well, thank you so much. Can we get a... Thanks, everybody, for coming out tonight. To our sponsors, of course, again, to Mike for talking us through a whirlwind tour of Elm, despite perhaps some adverse situations.
We held it together.
Yes. But we held it together, yeah.
I have one more thing to say,
yes.
Which is that even Evan has said that like the best way to start using Elm isn't to like start some greenfield.